So in this example, we have our function z, and here we have x, y, t, and s. And we can see that x is a function of t and s, and y is also a function of t and s, which means that the ultimate source of change in z comes from two sources, t and s. We are asked to find the partial total derivatives as follows. So our starting point needs to be to set out the total differential dz. Okay. Okay. Now we need to divide through by the relevant differential, and we are first examining the change in z when there's a change in t holding s constant. Okay, so we are finding the partial total derivative, and we need to use the notation to indicate that, and we're going to divide through the left hand side and the right hand side of this total differential by dt. Okay, and remember we have to use the partial notation, so the curly d. All right, so there we have it, and we can now go ahead and calculate this partial total derivative. So we start by partially differentiating z with respect to x. So let's do that. Y, okay, these terms don't have x. So now working with this function here, we need to partially differentiate x with respect to t. 3 plus partial derivative of z with respect to y, to end up with 8x squared. Okay, partially differentiate y with respect to t, we'd end up with minus 1 plus partially differentiate z with respect to t, so there's our term with a t in it, 8t. Okay, this is going to cancel to 1. And then with respect to this last term here, there is no relationship between s and t, so this here would effectively be 0, and this whole term would equal to 0, so this here would be our answer. In the second part of this question, you are asked to calculate the partial total derivative where we allow s to change, holding t constant. And our starting point would again be to set out the total differential dz. Okay, so that's written here. And this time we need to divide through by the differential ds. But of course we're going to use the notation to indicate that we are finding a partial total derivative. So let's do that. Okay, and using the curly D now. All right, so now we can go ahead and work this out. So we start by partially differentiating z with respect to x. Minus 8y. Okay. Partially differentiating x with respect to s. So that will give us 1. Partially differentiating z with respect to y, minus 8x minus 3y squared. Okay, and partially differentiating y with respect to s, we will get 2s. All right. And now if we just take a look at this term here, okay, we are asked here to partially differentiate t with respect to s, and clearly we can see that there is no relationship between these two, and this will end up being 0. So this whole term here would be 0. Okay, so if we move on to this final term, partially differentiating z with respect to s, going to end up with 3, and then this here would equal 1. All right, so we would end up with this as our answer.